Hi, my name is Madison Gomer, and today we're going to take a closer look into annealing. In most cases, annealing is used to reverse the effects of work hardening and can help achieve desirable properties. The 5 different types we're going to look into is full anneal, stress relief, process anneal, normalize, and spheroidice. First up is full annealing. This process includes heating steel to above the upper critical temperature and slowly cooling. Most commonly used for hot work sheets, forging, and casting, made from medium and high carbon steels. Full annealing makes soft steels, which increases formability, machinability, ductility, and toughness. It is also useful in relieving stress in the part caused due to prior cold working processes, because the plastic deformations present are removed during recrystallization. Next, we have stress relieving. This process heats the metal up to just right below its lower critical border and requires slow cooling process. This lengthier method is beneficial and will yield a part with lower internal stress resulting from plastic deformation, non-uniform cooling, and phase transformations. Process annealing, also referred to as isothermal annealing. This process involves heating the metal above the upper critical temperature and then cooled quickly to approximately 650 degrees Celsius and is held isothermally for a period of time. This causes the austenite to transform to ferrite and perlite. The part is then withdrawn from the furnace and allowed to air cool. Unlike full annealing, process or isothermal annealing only takes up to 4 hours and allows the part to be soft enough to undergo further cold working without fracturing. It can also negate effects of cold working by recovery and recrystallization. During normalizing, the metal is heated to a temperature that is 40 degrees Celsius above its upper critical temperature. After holding it at this temperature, the metal is then cooled in air. This relieves internal stress caused by processing and creates a uniform grain size. In normalized form, steel is tougher than in any other condition. This is why parts that require impact strength or need to support massive external loads will almost always be normalized. Lastly, we have spheroidice, and it is used for processing high carbon steels. It starts by heating the metal up and holding it at this temperature for a period of time to convert the microstructure. Cementite changes to alpha ferrite matrix, most commonly done on parts that have been work hardening to allow them to be further worked, which improves ductility and toughness with reduced hardness and strength. All right, so now we have a couple of examples. So first is aluminum, which is annealed to allow for extreme forming and drawing operations to prevent cracking and tearing. Then we have sheet metal. It is annealed to restore its ductility and formability, which allows for further bending, punching, forming, etc., without cracking or losing dimensional stability. Then we have metal wire, which often undergoes annealing because the process of drawing causes stresses in its grains, and annealing can remove this work hardening stress, which allows for specific mechanical properties. So I put this video in here. It will give you a visual of creating this ductile iron through annealing process.
After pipe are cast, a crane or conveyor transports them to the annealing oven. Inside this oven is where the pipe's final chemistry is set, and their transformation into ductile iron is complete. The pipe travels slowly through different temperature zones inside the oven, each with a specific purpose. The entrance is typically set at or near 1,800 degrees. Primary zones in the middle of the oven maintain a temperature between 1,400 and 1,500 degrees. The cooling zone near the end of the oven, where the most important ferritic structures of the pipe are formed, is set near 1,350 degrees. The annealing oven is fueled by natural gas and lined with refractory grade brick to maintain the heat within the oven and distribute it evenly. Pipe exit the oven as 60-42-10 ductile iron. Each pipe must have a minimum tensile strength of 62,000 pounds per square inch, a yield strength of at least 42,000 pounds per square inch, and an elongation factor of 10% to qualify for use in the marketplace.
All right, thank you for watching.